Value education, be valued live sporty. Welcome to Reference Frame, a lighthouse of mathematics.
Assalamu alaikum everyone, welcome to today's tutorial of reference frame. Hope all of you are doing well by the grace of Almighty Allah during this lockdown situation while you stay at home, and hope all of your family members are doing well by the grace of Almighty Allah. So kids, today I'm here with algebraic problems. Specifically, if I want to say, the specific topic is going to be algebraic formulae. I got a lot of requests that you're facing problems with algebraic formulae. That's while you're going to solve problem related to algebraic formulae, then you just being confused that how to apply the algebraic formulae and when to apply which formulae. So I'm here today to discuss about those kind of thing, that how to apply the algebraic formulae more smartly and when to apply it. Okay, so here we just need to keep one thing in our mind, that we just need to focus on the destination. Destination means that we're asked to find and our given value. That means that we are given, based on that, based on which information we need to reach into our destination. Okay, so please don't be panic. So in our these sequences, this is a consequences of several lectures or several tutorials. In our these consequences, inshallah, we're gonna discuss about algebraic formulae of order 2. Algebraic formulae of order 2. We're gonna discuss about the algebraic formulae of order 3 in some other tutorials after finishing the consequences of algebraic formulae of order 2. Okay, so please be with me till the end to get or to be benefited. I hope, inshallah, if you will be with me till the end, all of you will be benefited by the grace of Almighty Allah. Okay, so okay, let's move to start. Okay, in our today's tutorial, we're going to solve G based on the consequences of the previous problem. Look here, the same stem is given as you can see on the screen. Here the stem is p square minus thrice p plus 1 is equals to 0. Based on that same stem, we solved up to f in our last tutorial. So today we're going to start with this one. So look, we are asked to find the value of p to the power 4 plus 1 by p to the power 4. As you can see, procedure 1, actually here the procedure 1, procedure 2, look, p to the power 4 plus 1 by p to the power 4, we discussed it earlier that whenever we have the index 4, then we need to reduce them into second order, that means of index 2. So look, as far as we reduce them, we can write p to the power 4 like p square whole square, and instead of 1 by p to the power 4, as you can see, 1 by p square whole square. Now procedure 1, for look, if we consider this one as a square and this one as b square, look, in that case a square plus b square, and for a square plus b square we know two corollaries, right? That is why in procedure 1 we're going to apply a corollary, and in procedure 2 we're going to apply another corollary. So here we got the value p plus 1 by p from a. We're going to apply this value in procedure 1, and in procedure 2 we're going to apply the value of p minus 1 over p. Okay, so let us move forward. So if we apply the corollary of p square, p plus 1 by p whole square minus twice p into 1 over p, there you can see, look, p square plus 1 by p square whole square minus twice p square into 1 by p square. Here the side note, as you can see, look, here a square plus b square is equals to a plus b whole square minus twice ab. Now the fact is, all you need to do, look, p square plus 1 by p square. We discussed it earlier that always we first apply the plus corollary, and for the second step we apply the corollary based on the given information. So as far as we have considered the given information p plus 1 over p is equals to 3, that is why you're going to apply the corollary, this corollary again. Okay, let us move to apply this one. Look, now for the white portion, for this portion we're going to apply the corollary, and we're going to get p plus 1 over p whole square minus twice p into 1 over p, and this whole square is for, look, this whole square. Okay, Don't be confused. And look, this p square and this 1 over p square, they omit each other. So from here, what are you gonna get ultimately? Look, p plus 1 over p whole square minus twice p into 1 over p whole square minus 2. Because from here, p square 1 over p square vanish. Again, inside the bracket, look, this term will be vanished, p into 1 over p. Now all we can do, we can put down the value of p plus 1 over p. So if we put down the value, what are you gonna get? Let us move to say that, look, if we put down the value, then we're gonna have 3 square minus 2 whole square minus 2. Okay, now 3 square, its value is 9, so 9 minus 2 whole square, as you can see, 9 minus 2 whole square minus 2. So it's gonna be 7 square minus 2, which is 47. That means by applying procedure 1, that means by using the value from a p plus 1 over p is equals to 3, we got the value 47 of the desired destination. Okay, let us move by using the second procedure. Here the second procedure, we consider the value p minus 1 over p is equals to root over 5. Here p minus 1 over p, we got it from b. Now look, again we reduce the given expression or our destination, which is p square whole square plus 1 over p square whole square. And as per as we mentioned earlier, that we always apply the plus corollary first. So look, by applying the plus corollary, we're gonna get p square plus 1 over p square whole square minus twice p square into 1 over p square. So just like the previous one, this part will be vanishes. Okay, so let us move. Now look, in this case, for the inside part of the bracket or parenthesis, we will apply the corollary of minus 1. That means a minus b whole square plus twice b. Because look here, we're given the value of p minus 1 over p. That means the value compared to a minus b. So if we apply the corollary for the white portion, then we're gonna get, look, p minus 1 over p whole square plus 2 into p into 1 over p whole square minus 2. Now look, this part, they vanish each other or omit each other just like the previous one. Here the value of p minus 1 over p whole square is equals to what? Is equals to root over 5. Now you just put down the value. So by putting down the value, we're gonna get this one, the root over 5 whole square plus 2 whole square. Look, this square and this root omit each other, so you're gonna get 5 plus 2 whole square minus 2. As we can see, 5 plus 2 means 7, so 7 square minus 2, which is 47. So in both procedure, whether procedure 1 or procedure 2, whether we apply the value of p plus 1 over p or p minus 1 over p, we always got the value same for our destination, which is 47. Okay, let us move forward for the next problem. As you can see, this time, look, we need to find the value of p to the power 8 minus 47 p to the power 4 plus 1. Look here, the index is 8. And for the second term, the index is half of the first term, that means the index is 4. And on the third term, the index vanishes. So we discussed about this problem earlier, that we need to just think about this sign. So what is the sign before 1? The sign before 1 is plus. That means we will start our problem from p to the power 4 plus 1 by p to the power 4. How? If you have confusion with this one, please watch the earlier tutorial. There we discuss in details about this one. So look, p to the power 4 plus 1 by p to the power 4 is equals to 47. We just got it from G. But when we are asked to solve this one individually without G, then we need to first solve up to this line and then proceed the next lines. Okay, first we need to solve up to this line and then we'll proceed the next line. Okay, let us move. Here p to the power 4 plus 1 by p to the power 4 is equals to 47. We take LCM on the left hand side, just our previous problem. So here p to the power 4 into p to the power 4 is becomes p to the power 8 plus 1 divided by p to the power 4. Now if we do cross multiplication, then we're gonna get p to the power 8 plus 1 is equals to 47 p to the power 4. Therefore, what you're gonna get? Therefore, you're gonna get finally, if we shift 47 p to the power 4 one to the left hand side, so the sign before 47, which is plus, so you're gonna change the side by the transposition law, the sign will be minus, as you can see here. Therefore, on the red line, p to the power 8 minus 47 p to the power 4 plus 1 is equals to 0, which is our required destination that we are asked to solve. Okay, let us move into the next problem. This time we are asked to find the value of p to the power 4 minus 1 over p to the power 4. So look, just like the previous manner, we will reduce it on the square term, and from a and b we got the value p plus 1 over p is equals to 3 and p minus 1 over p is equals to root over 5. So look here, we apply the we just reduce it just like the previous problem. We have p square whole square minus 1 over p square whole square. Now for this portion we're gonna apply the formulae of a square minus b square, and here p square works as a and 1 by p square works as b, and by applying the formulae we can have, look, a plus b, that means p square plus 1 by p square into p square minus 1 by p square. Now look, for the blue portion, for this blue portion we can apply the formulae again, the same formula again, and for the purple color portion, that means for this portion or light violet portion, we're going to apply the corollary. Now for this one we can apply either the corollary using p plus 1 over p or the corollary of using p minus 1 over p. Okay, let us move forward. Look, for the blue portion we have written p square minus 1 by p square. For this part we have written p plus 1 over p into, oh sorry, this must be p minus 1 over p, I beg apology, this one will be minus, this sign will be minus, I beg apology for my typing mistake. Okay, so please correct it while you solve it by yourself. Now for the inner portion or the purple color portion we apply the corollary using the plus value, and there we get p plus 1 over p whole square minus twice p into 1 over p. So look, this portion omit each other, and finally what are we gonna get? We just need to put down the value. So here the value of p plus 1 over p is equals to what? 3. P plus 1 over p is equals to 3, and this is p minus 1 over p. I repeat, this will be p minus 1 over p, this sign will be minus, so p minus 1 over p value is root over 5. So if we put down the value, what are we gonna get? As you can see, root over 3 square minus 2 for these two, because p and 1 over p omit each other, and from here p plus 1 over p is equals to 3, and for this portion, since this is p minus 1 over p, this is 3 into root over 5, and 3 square minus 2, which is 9 minus 2, that means 7. So 7 into 3 into root over 5. Now you're gonna get, look, 7 into 3 into root over 5, finally you're gonna get 21 root over 5. Now look here, we apply the corollary using the plus value. If we apply the corollary using the minus value in procedure 2, what do we gonna get? Okay, let us move forward to say that. Okay, just like the previous manner, this is just like the previous one. We'll directly move into the next step. So again here, look, for this portion, I beg apology, here the sign will be minus. Okay, this sign instead of plus, this will be minus. Now look here, for the purple color portion, only the change occurs for the purple color portion, as you can see. So here p minus 1 over p, in the previous problem what do we apply? We apply p plus 1 over p, but this time we apply p minus 1 over p whole square plus 2 into p into 1 over p. Here p and 1 over p omit each other. Now all we need to do, we just need to put down the value. So p minus 1 over p, value of this part is what? Root over 5. So here root over 5 whole square, value of p plus 1 over p for this portion is 3, and for the next portion, that means p minus 1 over p, I told you that this will be p minus 1 over p, its value is root over 5. Here this sign will be, this sign will be minus. So if I put down the value, we're gonna get root over 5 whole square plus 2 into root over 3 into root over 5. Look here, square and root omit each other, so here we're gonna get 5 plus 2, that means 7 into 3 into root over 5, as you can see here. And finally we get the destination, the 21 root over 5. That is, whether we apply any of the corollary, that doesn't matter, for the same destination based on the same given information, we always get the same result. Okay, let us move into the next and last problem of today's tutorial, which is just like the previous one. P to the power 4, we need to show that p to the power 8 minus 21 root over 5 p to the power 8 minus 1 over 5. Look at this, this time the sign before 1 is minus and rest is 8, half of 8 and vanish. So here, since the sign is minus, so you're going to start with p to the power 4 minus 1 over p to the power 4, and which is equals to 21 root over 5. Just like the previous one, if we asked to solve this problem individually, then first we need to find out the value of p to the power 4 minus 1 over p to the power 4 by the procedure of I that is solved earlier. And now if we take LCM, here LCM is p to the power 4 just like the previous problem, and there we get what, p to the power 8 minus 1 divided by p to the power 4, and we cross multiply, we get p to the power 8 minus 1 is equals to 21 root over 5 into p to the power 4. So if we shift this portion onto the left hand side, the sign will be minus, as you can see with the red color portion. Therefore finally we're gonna get p to the power 8 minus 21 root over 5 into p to the power 4 minus 1 is equals to 0, which we asked to show. So with this problem we solve different categories problem by applying the formulae of algebraic formulae of second order. Inshallah we'll come up with some other advanced level problem. Okay, so kids, hope you enjoyed today's tutorial, and I'm very much hopeful that this will be helpful for you to solve algebraic problem regarding to algebraic formulae of order 2. So all you need to do while you stay at home, you just solve some problem related to the problem that is solved in today's tutorial. Okay, because the more you practice, the more you will be adroit. Adroit means the more you will be capable that when to apply algebraic formula for which problem, okay, and how to apply it more smartly, and how to solve any algebraic problem by applying algebraic formulae of order 2 more easily, okay, without agonizing pain. Okay, so inshallah we'll see you in the next tutorial with some other problems and some other algebraic problems regarding to algebraic formulae of order 2. Till then, please stay safe, stay home, stay sound, and please keep me in your praying. May Allah bless all of us, and may Allah forgive us to overcome this hard luck situation of COVID-19 pandemic outbreak. Okay, all of you please be blessed by Almighty Allah. Assalamu alaikum wa rahmatullahi wa barakatuh.
Share your idea to build a happy Bangladesh.